All right, so this is section 1, topic 9. It's part 2 of parallel and perpendicular lines. So it's a continuation of where we were before. So in the last lesson, we learned that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So the opposite flipped upside down slopes. The other thing that we're going to need to use in this lesson is point slope form of a line. In the last lesson, we used slope-intercept form, which is the most common way we use to graph equations of a line. And obviously, slope-intercept form uses slope and the y-intercept, and point slope form uses the slope and one point on the line, any point on the line. This one specifies that the point on the line is going to be the y-intercept. So point slope form we will have looked at in class, and just will remind you of what it looks like when we get down to this problem. All right, so this says write the equation of the line passing through. Look at this. They gave us a point and perpendicular to this. Perpendicular, remember, opposite reciprocal. So we're going to have to find the opposite reciprocal of this slope, but this is not ready to look at to find slope because it's not in slope-intercept form. So we're going to do our little bit of algebra here to move your x over to the other side, and we're going to try to get y by itself so we get in slope-intercept form. So subtract x and move it to the other side. We have 2y equals negative 1x plus 11, and then divide through by 2. And remember, if you divide one thing, you're going to divide all things. So every single term gets divided by 2. And this one comes out to be y equals, there's a 1 there, negative 1/2 x plus 11/2. All right, so this one has a slope of negative 1/2. But it said that we wanted it to be perpendicular to negative 1/2 slope. So we are going to have to do the opposite. Opposite of this would be positive, and the reciprocal would be 2/1, which is just 2. So the slope that we're going to use will be 2, and the point that we're going to use is negative 1/4. Now we're going to go ahead and plug that in to our point slope form. All right, so point slope form, just as a quick reminder, is y minus the y coordinate right there equals the slope times x minus the x coordinate right there. And then we just have to plug these numbers in. So we get y minus the y coordinate, which is 4, equals slope. Don't forget, we just determined our slope over here is 2, times x minus the x coordinate, negative 1. So this is y minus 4 equals, okay, 2 times x minus a negative means plus, right? Minus a negative is plus a positive. All right, distribute your 2 in here. On our next line, we get y minus 4 equals 2x plus 2. And add 4 to both sides to get y by itself. And we have y equals 2x plus 6. There we go. That is the equation of the line passing through this point perpendicular to this line. So we had to find the slope of this line, make the perpendicular slope, plug point and slope into point slope form, and write it in slope-intercept form. So there are a lot of steps involved in that. All right, let's try another one. Suppose the equation for line A is given by this. Ooh, it's in slope-intercept form. That's nice. If line A and line B are perpendicular and the point negative 4, 1 lies on line B, then write an equation for line B. Okay, so we are going to use point. There it is. That's our point. And our slope here, this is our slope of the current line, but we need it to be perpendicular. So negative 3/4 being our original slope, make it perpendicular. We're going to do opposite reciprocal. So there we go. This is the slope we're going to use and the point we're going to use. So put the slope and point into point slope form. All right, here we go. Y minus the y coordinate 1 equals slope times x minus the x coordinate -4. There's that double negative again. Be careful of those. All right, y minus 1 equals 4/3 times x plus 4. Go ahead and distribute, or to simplify your double negative there. Now distribute your 4/3. We get y minus 1 equals 4/3 x plus 4 times 4/3. Okay, remember, multiply your numerators, multiply your denominators. That's 16/3. Add 1 to both sides. To get rid of it, get y by itself. Y equals 4/3 x plus, this is fun, 16/3 plus 1. We need these to have common denominators, so let's call 1 3/3. And that's added together gives us 19/3. I know that looks a little ugly, but that is exactly what we're looking for right there. There is the equation of our line. All right, moving on. Name a set of lines that are parallel. Justify your answer. Okay, well, these appear to be parallel, but there's no symbol here that shows us. Remember, we'd have to have those little arrow symbols on both of those. But we're going to go with the fact that we think those are probably parallel, and we just have to justify it. But remember, parallel means they have the same slope. So we just have to determine the slope of both of these lines. So pick 2 good points. They've already got 2 good points here for us. And start with your left one. Rise and run to get to the other point. So rise, 1, 2, 3. Run, 2. So line P has a slope of 3/2. Positive, you can see it's going uphill, so positive makes sense. All right, let's double check this one then. There's 1 point. We just need another good point. Looks like that would be another good point right there. Rise again. Start with your left one. Rise 3. Run 2. Look at that. There you go. This slope also is 3/2. Okay. So name a set of lines that are parallel. Line P is parallel to line R. Justify your answer. Because they both have slopes of 3/2. There you go. All right, next one. Name a set of lines that are perpendicular. Justify your answer. Okay, perpendicular, 90-degree angles. They form right angles. And this looks like those are perpendicular. In fact, this line then would be perpendicular to both of these lines. So we just really need to find out what this slope is to see if perpendicular, if it is opposite reciprocal of 3/2. And what is the opposite reciprocal of 3/2? -2/3. Okay, so is that the slope of this line right here? So find 2 good points on that line. This is a little harder. Oh, well, they've got two identified for us. Let's use those. So let's use this one and this one. I always start with the left-hand one. This is going downhill, so we got to know that that's negative. Start with the left-hand one, and we are dropping. There's our negative. 1, 2, 3, 4. That's a -4 drop. And run. 1, 2, 3, 4, 5, 6. We can also look at our coordinates here. The drop, this is going in the y direction, so let's look at our y coordinates. This one is at 1, and this one is at -3. To get from 1 to -3 is a drop of 4. And then in our x direction, left, right, we're going from -1 to +5, which is going 6 steps in the right direction. All right, so our slope here is -4/6. So the slope of line N is -4/6. Oh, no. Yeah, -4/6. which simplified is negative 2/3. All right, was it? Yes. So yes, they are perpendicular because the slopes, 3/2 and negative 2/3, are the negative reciprocals. I totally missed writing that where you could see it. The slope of n came out to be negative 4/6. That is negative 2/3, which is the opposite reciprocal of our original slope, what we were looking for. All right, moving on. All right, beat the test. The equation for line A is given as this. Suppose line A is parallel to line B and line T is perpendicular to line A. Point 0.05 lies on both line B and line T. All right, so let's take this one step at a time. The equation for line A is this. Suppose A is parallel means same slope, to line B. Point 0.05 lies on line B. So we have a point and slope, same slope as this one. And this is already in slope-intercept form, so we can see the slope right there. All right, so line B has a point of 0.5 and slope of negative 3/4. So let's go ahead and plug those into slope-intercept form here. We have y minus y1 equals slope times x minus x1. All right, so y minus the y coordinate, which is 5, equals our slope times x minus the x coordinate 0. Well, x minus 0 is just x, so we don't really have to work on that too much. So this is y minus 5 equals negative 3/4 times x. Add 5 to both sides, and we get y equals negative 3/4 x plus 5. Okay, so this is line B. Give me an arrow right there. Okay, there's our equation for line B. Write an equation for line T. All right, T is perpendicular to line A, so that's opposite reciprocal. So the slope of line T, line T also has 0.05. See, it says 0.5 lies on both line B and line T, so it has a point of 0.5, and its slope is the opposite reciprocal of negative 3/4. So opposite of negative is positive, flip it 4/3. And we're just gonna do the same exact process we did before, which is y minus the y coordinate equals slope times x minus the x coordinate. Y minus 5 equals 4/3. Remember, that was just x, so multiply that. There you go. And add 5 to both sides, and you get y equals 4/3 x plus 5. This is the equation of line T. There you go. All right, we've done that a number of times. It should be feeling a little bit better. All right, let's go to this last question here. A parallelogram is a four-sided figure whose opposite sides are parallel and equal in length. So a parallelogram typically looks like this. Alex is drawing parallelogram ABCD on a coordinate plane. All right, something you should know about naming figures like this is that it's always named in the order they give it. So start wherever you start, that's where you're gonna just continue around the figure in that direction. So for example, if this were point A and this were point B, this has to be C and that has to be D. It has to follow all the way around. If we did it like, oops, I didn't draw that very parallel. If we started A here and took B here, then this has to be C and that has to be D. They have to stay in the order that the parallelogram is listed in. All right, so the parallelogram has coordinates A is at 4, 2, B is at 0, -2, and D is at 8, -1. They didn't include C in our list, and they haven't given you a coordinate plane, and a coordinate plane would make that a whole lot easier to do. We're going to do an estimate graph, just to kind of see where we are with these. So point A is at 4, 2. Point B is at 0, -2. Point C is not on this, but look, this is A and that's B, which means we are going to have to start here, go here, which means C would be next, and D is leading back up to A. And D is at 8, so twice as far, -1. So there's D at 8, -1. All right, D has to lead back up to A, all right? A, B, C is down here somewhere. D, A. All right, so which one makes sense? Let's see, 6, -3. Would put it about here. How about 4, -5? That looks pretty reasonable. 10, -3 is way out there. That's completely unreasonable. And 4, +3 is up here. That's completely unreasonable. So it's one or the other, and it looked like this one was a little more favorable. So we're gonna attempt this one. We're gonna say, what if C is 4, -5? We're just gonna try that one out. Okay, if it is, then either we check this side and check to see if their slopes are parallel. And we do this side and see if their slopes are parallel. And that would give us a parallelogram. So let's check this slope right here. So rise is going in the y direction, and that means from -2 to +2, which is a rise of 4. And a run, that's from 0 over to 4, is 4. So rise 4, run 4 gives us a slope of 1. All right, let's see if this one would give us a slope of 1. So rise from -5 to -1 is a rise of 4, and run, our x's from 4 to 8 is 4 also, so that gives us a slope of 1. Okay, so these are definitely parallel. If these two are parallel, then we're good. So let's check here. I always start with my left-hand one. Let's use a different color. This is going to be dropping. This is a negative slope, so I'm dropping from -2 to -5. That's a drop of 3. And running from 0 over to 4, which is a run of 4. So this has a slope of -3/4. Let's see if this one also has a slope of -3/4. So drop from 2 down to 1 is a drop, or 2 down to -1 is a drop of 3, and we already determined that was a run of 4. So this also has a slope of -3/4. Okay, so this worked. This is the point we were looking for right here. There you go. All right, that one was pretty long and complicated, but at least you've seen one like it. So if you ever run into one kind of like this, maybe that'll work. Good luck.